Hello, welcome back. This is episode 6 of the fuel injection project. So last time we looked at the crankshaft position sensor. I still haven't attached the aluminium insert that's going into the crankcase yet, so I'll do that later when I've removed all the paint from the crankcase. Because of the epoxy, I want a good bond. So today we're going to be looking at the actual intake setup. As you can see, I've got a sort of empty engine partly assembled here to do a bit of a mock-up of a mock-up of the intakes. 3D printer comes in really handy for this kind of thing because you can print them and see how it's all going to fit. And if it's not right, you just print another one, change the design slightly, so much easier. So I've got a bunch of 3D printed, not failures, but earlier versions. So that's what we've got at the moment, and it's all fitting quite well actually. I've had to put the injectors and the injector rail, the fuel rail, at the top. There really wasn't space to put it underneath. There's a few cast features in the crankcase. The housing for the starter motor, and then also the obviously the cam chain tensioner. That's not such an issue because you can always put a manual one on, but to be fair, with the manual one you wouldn't really be able to reach it without getting all of this out, removing all of this. So just setting your cam chain tension would be a bit of a problem. So I think I might still do that, to be honest, because I'm not a huge fan of these auto tensioners. But I don't know yet, haven't decided. But either way, fuel rails got to go on top, and then you've got your throttle bodies here. I've got these foam filters. I don't know if I'm going to keep them. We're going to try them and see what happens. They didn't need a lot of modification to fit. And then there's the 3D printed adapters. And then you've also got some nipples at the top for the idle air control valve. So I didn't include them in the print, they came after because I wasn't sure how I was going to lay it all out yet. So I just glued them on. So for now, just as a mock-up, everything seems to fit. I'd like to have the idle air control valve at the top rather than the bottom because there's a lot more options for mounting it because you've got frame rails up here, so you've got places to mount it, whereas underneath I noticed there aren't really many places you could mount the actual valve itself. So we'll have that at the top, plus it's on the same side as the fuel injectors, which I thought is probably better because it's a bit closer to the injectors than it would be on the TT600, and I didn't want to run the risk of any fuel being injected into the tubes for the idle air control. So having it on the same side is probably better. There's a few parts that'll need to be made, obviously, to make this all work. I did look at at these little adapters and what to make them out of and how to make them. And to be fair, there's a lot of different ways of doing this. I do have a CNC milling machine, so the obvious first option is to mill that from aluminium, but it's a complex shape and it's going to need fixturing, and there's probably 10 operations on each of these. They're all completely different, and they'll need fixturing for all of those operations. So not overly keen on having to make all of those fixtures. So I thought, is there another way of doing this? I mean, you could probably cast that in aluminium. I've never tried aluminium casting before. It probably wouldn't be too difficult, but it's an unknown, so I decided against doing that. I've also seen some 3D printed ones in use on cars where they're printed directly in things like carbon-filled nylon. I did buy a little sample of a carbon-filled nylon filament, and I had a go at printing some test pieces. I did find it quite difficult to print. It's extremely hygroscopic. It's very difficult to get a nice finish on it. I think it might be possible, but to be fair, with my printer, I think it's probably going to be more effort than it's worth, really. So another option is forged carbon, which was in the end the sort of direction I think is best to go in, because not only is it good for something like this because it's fuel resistant and it's tolerant of heat if you use the correct resin, a high temperature resin. But also, I think there's loads of other little custom parts I'm going to have to be making for this motorbike. So I just thought, if I can get that process working, it's going to be useful for other things as well. And it's not very expensive. And if you're working with 3D printed molds, it's relatively, low labor. It's not quite so labor intensive as manning a CNC milling machine through all of that. So to that end, I did a little test. Now I've got some stuff from a company called Easy Composites. They've got some really nice videos on their website about how you use the old forged carbon, how it all works. Videos on YouTube as well. And basically, you make a mold. Loads of ways of doing it. One way is to 3D print it in PETG. So you make a mold, you fill the mold with this stuff. This is what they call chopped tow. It's chopped strands of carbon fiber, and it's dry carbon fiber. And then you alternate filling the mold with your pre-mixed resin and your carbon fiber until it's full, and you have a calculated amount in there. And you make sure that when you close your mold, it's got some squish, that the part you use to close the mold is actually compressing everything, and you clamp it in a vise and squeeze the whole thing. And in theory, that squeezes out the excess resin, consolidates everything, allows the fibers to move around and fill any, all the voids in the cavity, and let that set. And then when you demold it, you've got your physical part in a medium that's a proper structural medium. It's proper carbon fiber. So I thought we'll give that a go. Unfortunately, the mold did not survive very well. It needed a bit of persuasion to get apart, of the non-gentle variety. This is the part that ended up coming out of it. Now, this wasn't a success because one of the little elements, one of the features didn't mold correctly. It actually stuck to the other half. I think it didn't have an undercut. It was vertical, but it needed some draft on it to release. So lesson learned. Also, I mixed up everything and I added the carbon in the volume as they recommend for the volume to fill the cavity in the mold. So it was the appropriate amount of carbon according to their website and calculations. But I think the last 5 mil of closing of this thing was just so difficult. I had to stand on the vice handle to get it to close. And I was actually surprised that the mold held up to that. But it had a lot of bolts bolting it all together. But in the end, I think it was too much carbon, because it actually bulged out in some places where it compressed the mold. And I didn't go with a huge amount of infill. I only went with 50% infill, but the gyroid infill is quite sturdy. And to be honest, this is already half a kilo of 3D printer filament, so I didn't really want to have to use more than that. So I could probably have used a higher level of infill to prevent that. But I think the reason it happened wasn't necessarily because the mold was wrong. I think it was just because there was just too much carbon fiber in there. Plus, I was compressing it from this side. That was the closer. It's now distorted beyond measure. But it was closing from that side. And I think these flat surfaces didn't provide much movement of the carbon fiber to go in and fill the rest of the cavity up. So yeah, partly the mold design, partly I think an excess of carbon fiber, but even so there were still a few voids on the surface, but I'm not too worried about them. I feel like sort of treating this a bit like a casting in a way. I blanked out the holes to be machined in later. I think if you treat it like a casting, understand that there's going to be a bit of post-cast work to be done, a bit of filling, a bit of filing and burrs to remove. But on the whole, I'm calling it a semi-success. I've learned from it, and I think the next one will be better. But it is. It does. It is. If it wasn't for the issue with some of it staying behind in the mold, it would have been a usable part. That, even though it doesn't look pretty, it would have been a usable part. So I'm going to persevere a bit with this. The next video I think I'm going to do on this process, and we can see if we can get some, you know, good quality components out of it. But to be fair, I'm pretty confident we will. I mean, this is the way the mold went together, so a little bit awkward because you've got that big lug where your fuel injection is going to go in, and then you've got the flange, and they're not aligned to each other, so it makes the split line a bit difficult. So the split line is here and then steps out so that you're not undercutting that bit, and that just goes together like that, and that forms your cavity there for your part. And then there's this insert, which is now completely distorted, that fitted in here that way around to create your core, the hole in the center. And then there's this part that closed over that and compressed the whole lot together. So the basic idea seemed to work. I was kind of expecting this to stay stuck in the part. I didn't think I'd be able to get that out under, you know, normal circumstances. I did use a mold release agent, which was this PVA stuff, but I think that's a part of the problem. I think this is going to work better with the spray wax that they have on the Easy Composites website. So I've ordered some of that for the next try. But this didn't come out. There was no way to get that part out. So to be honest, because this also fits inside the closer part, that didn't come out either. So I was left with both of these parts firmly attached in there. So this ended up going in the oven at 100 degrees for a little bit just to heat up. And once you've heated it up, it's pliable enough that it's pretty easy to get off, but then it's not reusable. So I did expect to probably have to sacrifice this part. I didn't expect to do that one too, but at the end of the day, it doesn't really matter all that much. So next design, I think I'm going to make these sacrificial parts. Also, I think I'm going to change the design to be cylindrical rather than square, mainly because I put 11 bolts in there, M5 bolts, to clamp it all together. But I think what would have been a lot easier is just a few hose clamps. So if I make it cylindrical and I can fit hose clamps around it, clamp it all together, it's much easier to remove. But also the hose clamps, because they envelop the whole thing, they should probably give you a lot of strength in there. And then I'm also going to reevaluate the amount of carbon I put in there. I think I'll take a couple of mil off that, off the allowance for that flange, and hopefully that's going to be a little easier to compress. And then we'll have another go. But I'm pretty confident this will work. And if I can get this down and consistent, I think it's a useful manufacturing method that's going to come in handy for other components of the build of the bike. So, because I know there's a load of custom parts that are going to be needed. So yeah, on the whole, call it a semi-success. I'm happy with the layout up here. I think it looks all right. It actually looks kind of badass. I've also had a look at the coolant temperature sensor, which is now an oil temperature sensor, and I took the little plug that lives over there out and machined it down and tapped it out so that it forms a sort of adapter, and this sensor can just live in that area right there. So no engine modification needed for that at all, and it'll just once I've done a bit of painting and I've Loctited a few bits, I'll be able to screw that in there quite easily, and then that'll just have a plug on it going straight into the wiring harness. So yeah, so that's all okay. Very happy with the layout. So I think that's it for now, and then next video I'll do a bit more information on this forged carbon process, and I'll do a video on the whole thing, and we'll see how that comes out. But yeah, I think, to be honest, with a bit more tweaking, it might be possible to even create this part with the holes already in place, which would be ideal if you don't have access to machinery. But so this is a process that I think could be quite easily replicated without the need for CNC milling machines, which was quite useful. Obviously, though, I'll be using mine to do various finishing operations on there. So yeah, thanks very much for watching.